I can write the recursive rule for an arithmetic sequence. Here's what you need to know. An arithmetic sequence is a type of sequence whose pattern has a common difference. This formula is on your formula sheet for the Georgia Milestones exam, so you do not necessarily need to memorize it, but this is something to be familiar with. The recursive rule for an arithmetic sequence looks like this. We already know that a sub 1 just means the first term. Here's your actual, the rest of the rule right here. A sub n, which means any term that you want, the nth term, it could be the 100th term, the 52nd term, the 3rd term, whatever number is right here for n, that just means whatever term you're talking about. Any term that you're talking about is equal to the term that comes before it, because we're subtracting 1 from that value, plus the common difference. The recursive rule for a sequence depends on a previous term. This means that any term I want in my sequence is equal to the term that comes before it plus whatever my pattern or my common difference might be. Here's an example. Write the recursive rule for this sequence, 10, 7, 4, 1, ... It keeps going forever. Here's your recursive rule up here. Now, both pieces are important when you're writing the recursive rule. Both of these are the recursive rule. So we're going to start by listing our first term. We need our first term, which is the one that you see first. That would be 10. And then we also need these values right here. Now, a sub n is anything we want. We don't fill that in, but we can fill in some of these other pieces. The common difference as we're looking at the sequence is -3. That's because we are adding -3 every single time we move down the list. So here's the recursive rule. We just fill in the pieces where they go. A sub 1 equals 10. And any term we want is equal to the term that comes before it minus 3. And you could test this out if you wanted to. You could go pick any term you want, and the way that you would get that term, such as 4, would be to grab the term that comes before it, which would be 7, and then use your common difference, which is -3 or subtracting 3. So that entire thing, again, is the recursive rule. Pause and try this one. Write the recursive rule for the sequence 2, 6, 10, 14, and so on. Here are the pieces that you needed. The first term is 2. The common difference is 4, +4, because we're adding 4 between the terms. And we're going to fill in the pieces where they go. Here is the recursive rule for this arithmetic sequence. Your next learning target, I can write the explicit rule for an arithmetic sequence. So we always have two types of rules for these sequences. We have the recursive, which we just learned, and the explicit. Just a reminder, arithmetic sequences are the type whose pattern is a common difference. Again, this rule or this formula is also on your formula sheet, but we're just going to break down where the pieces come from. A sub n is your nth term. It could be any number you want. D represents the common difference. N is whatever term position you're interested in. Maybe you want to find the 5th term or the 6th term. That would mean n is 5 or 6 or whatever it is that you're looking for. And then at the end here, a sub 0 is equal to your first term minus your common difference. So this is like working backwards. A sub 0 is going to be something that you don't see in the list of numbers. It would be what would come before the first thing you see if you were to work backwards. The explicit rule for an arithmetic sequence is just like the slope-intercept form of a linear function. So the thing that you care about, or your output, is equal to some common number times your input plus whatever your y-intercept or your initial value is. So I've color-coded it here for you. All these pieces do match up, and you'll see that in just a second. The explicit rule of a sequence does not depend on a previous term. So when we are looking at writing the rule or the equation for a sequence, the explicit rule is most of the time going to be the easiest one to use because we don't have to do a ton of work to fill in all of the missing pieces. For example, if I wanted to find the 100th term, using the recursive rule would mean I'd have to find the 99th term, which means I would have to find the 98th term, which means I would have to find the 97th term, and so on. We would have to do a lot of work. Whereas the explicit rule, we won't have to do as many steps to figure out what the 100th term would be in whatever sequence I'm looking for. So the explicit rule is a lot more handy. It's a lot more practical to use this one. Unless something specifically tells you to use recursive, the explicit rule is going to be the one that we use most of the time. Here's an example. Let's write the explicit rule for the same sequence that we just dealt with, 10, 7, 4, 1, ... Let's go find the pieces that we need. We are going to need to find the common difference. Our term position is very vague here. It doesn't say, hey, go find the 3rd term, go find the 11th term. So we can leave that alone as n. But we are going to need to go find the a sub 0, which would be the term that comes before the 1st term. So we'll work backwards to figure out what would come before the 10. I know my first term is 10. I know that my common difference is -3. So if I work backwards, I can take 10, subtract my common difference, and I would find out that my a sub 0 term is 13. So if I were to envision this list going the other way, 13 would come before 10, and we're going to need to fill in this value into our rule. Now we just fill in the pieces. A sub n is equal to -3 times n plus 13. And now that we have the recursive rule, I could say, hey, go find the 100th term, or go find the 51st term, go find the 1000th term. And you would just plug that number, whatever term you care about, in for n, and simplify using your order of operations. It's a really easy way to find specific terms in your sequence. Pause and try this one. Let's go find the pieces that we need. Your first term is 2, your common difference is 4, and if we work backwards, we find the term that would come before 2 would be -2, and now we'll put those pieces into the recursive rule where they go. That should say explicit, I'm sorry, the explicit rule. A sub n is equal to 4 times n minus 2. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.